Today I'll be going over heat of vaporization and specific heat. For this question, you'll be asked to heat up 1 kilogram of water from 4C to 100C and then to boil it all away. And just for fun, we'll use TNT to do that. So the energy content of TNT, as calculated by the bond dissociation energies, is 3,290 kilojoules per mole. This isn't the actual value, this is the value calculated from bond dissociation energies. It's a theoretical value, assuming complete combustion. We'll use it for this question. So, if you're asked to heat up water from 100 degrees C to 4 degrees, or from 4 to 100 degrees C, we'll be dealing with this temperature change of 96 degrees. And if you know the specific heat of water, 4.1186 kilojoules per kilogram degrees C. So we have a temperature change, cancels out with the degrees C here. If we're looking for kilojoules, then we also need to multiply by kilograms. We have 1 kilogram of water. Now our answer is in kilojoules. So that's degrees C times kilograms divided by degrees C gives us just kilojoules. Now we can figure out how many grams of TNT we'll actually need. So if we have kilojoules, we divide by this number here, 3,290 kilojoules per mole. Divide by kilojoules, so now we have this answer will be in moles. And if you know the molar mass of TNT, which is 227.13 grams per mole, now our answer will be in grams. If you look at all the units, they'll cancel out. Degrees C, kilograms, kilojoules, moles. We're left with just grams. So our answer will now be in grams. So what is that answer? You should get, if you multiply and divide all this through, 27.7 grams of TNT. Now, for the part 2 of this question, this is just to heat the water up to boiling. So you went from 4C to 100C. Now you actually have to put in more energy to boil it away. Right now the water is liquid at 100 degrees C and you want it to be gas at 100 degrees C. So you have to push those atoms, you have to make them expand almost 400 times in volume. So that's going to take a lot of energy. In fact, a lot more than this. So let's look at that next part. We're given HV, the heat of vaporization of water, is 2260 kilojoules per kilogram. And we have 1 kilogram of water. And if we multiply these together, we'll get 2260 kilojoules, right? Pretty simple. And then now we know the amount of energy we need. We do the same thing we did up here. Divide by the energy content of TNT, which is 3,290 kilojoules per mole. And multiply by the molar mass, which is 227.13 grams per mole. And again, look at the units. Kilograms cancel out with kilograms, kilojoules cancel out with kilojoules, moles cancel out with moles, and once again, we're left with grams. And if you multiply through, this answer will be about 156 grams of TNT. So here we have using the specific heat of water, and here's the specific heat of water, and the heat capacity, and the heat of vaporization of water to calculate how much energy we will need to change the temperature of the water and to boil away that water. And we can use the energy content of a fuel and the molar mass of that fuel to figure out how much fuel we'll need to accomplish such a change. For more information, you can come to my workshops Wednesdays at 6 p.m. in Brown West 210, or my office hours Mondays and Wednesdays from 2 to 4 p.m. In Casa.